Today I'm going to go over circles in Edmentum and Plato, Unit 2. The very first section in Unit 2 in Geometry B talked about circles. But can be used for Algebra 2 kids, anybody who needs to know about circles. So here we go. So there's two different forms. There is general form, which is when everything is all on one side and zeros on the other. And then there is standard form, and standard form is the one we love. We love standard form because standard form will tell us the center of a circle and it will also tell us the radius. So we know by looking at this, you're going to learn that we can identify the center of the circle is going to be +6 and +4. And the radius is going to be, 56 is not the radius, but that's r squared is 56. So if we take the square root of both sides, then r is the square root of 56. And if you grab a calculator and do the square root of 56, that's going to be approximately 7.48. So we love standard form because it will tell us the center of the circle. So remember, when we're talking about the center of the circle, that's your center, and then the radius, your radius would be about 7.48. And then the coordinates of the center of the circle would be 6, 4. Right, so those are the coordinates of the circle. Okay, so again, standard form is what we love, and this is the formula for standard form. And notice that your H and your K, what creates the center of the circle. And then remember, this is r squared. So let's practice. First of all, let's practice if we have something in standard form, how can we identify the center? Now notice that this is a -h and a -k, so it's actually going to be the opposite of what you're seeing. So let's practice that, and then we're going to look at how to transform something from general form. This one's not very friendly, right? It doesn't really help us out a whole lot, but how do we get general form into our favorite standard form? We're going to go over that as well. So here we go. So identify the center and the radius of each problem. So I'm going to say C for center, or I guess I'll just write center. So what are the coordinates of the center? The coordinates of the center are actually going to be -6 and +3. So that would be the coordinates of the center. And then what would the radius be? Well, the radius is not 25. Remember, this is actually r squared. So r squared is 25. So to undo something squared, you have to take the square root to undo the squaring, and that will give you the r by itself. And so this is going to be 5. So the radius is 5. Let's look at number 2. Why don't you try number 2? Stop the video and you try number 2, 3, and 4, and then put the video back on. So let's see how you did. For the center of the circle, did you say it was +8 and +1? Did you say for the radius? Remember, 16 is not r. 16 is r squared. So you have to take the square root of both sides to get r. So r actually equals 4 because the square root of 16 is 4. And do you know where your square root key is on your calculator? Number 3, notice there is no h and k. So there is no h and k. So what do you think if there is no h and k? Did you say 0, 0? Very good if you did. And then what's the radius? The radius would be 7 because remember this is r squared equals 49. Therefore, when you take the square root to get r by itself, you get r equals 7. What about number 4? I'm just going to put C for center. Did you get the center as 0, -5? And did you say the radius was? So remember, r squared equals 8. So therefore, when you take the square root to undo the squaring, that gives you that r equals the square root of 8. So sometimes they'll write it in simplified radical form. So it depends on the expectations of your class. So sometimes we like to simplify our radicals. So you could write that as r equals 2 square root 2. And if you grab a calculator and actually do the square root of 8 on your calculator, you're going to get approximately 2.8-ish. So there's that. So how to identify the center and the radius. Next, when we have something written in general form, how do we go about getting it in standard form? This is what we're going to do. We're going to use what's called completing the square. So if you need more practice with completing the square, you can go to YouTube and search completing the square for extra help on completing the square if this video is not good enough for you. When you create it from general form to standard form, the first thing that you have to know is the coefficients of the x squared and the y squared has to be 1 first before you do anything. So therefore, we're going to divide every single term. That's what that means. We're going to divide every term by 2. And if we divide every term by 2, then doesn't that give me x squared plus y squared minus 12x minus 4y minus 2 equals 0 when I divide every 2 by 0. So again, I want to emphasize, before you can complete the square, the coefficients of what we call the quadratic terms must be a coefficient of 1. So now we can complete the square. So here what we're going to do is the constant is the term that has no variable. So we're going to move the constant over to the other side. Don't forget, when you pick up a term and you move it to the other side, you got to remember to change the sign. And at the same time, we're going to organize all the x terms next to each other, and we're going to organize all the y terms next to each other at the same time. So that's going to give me x squared minus 12x, and we're going to put plus because we're going to leave room for a new constant. And then plus, now I'm going to put the y stuff next to each other. And remember, I'm going to leave room for a new c for the y stuff. I'm going to move the negative 2 over to the opposite side, so that becomes a positive 2 on the opposite side. So this is going to be our new c. So there is a formula to help you find that new c. So that formula to find your new c is going to be to take the b, divide it by 2, and then square it. And that's how you're going to find your new c. So to find this new c, we're going to take the b, and the b is the coefficient of the linear term. So we're going to take negative 12, divide it by 2, and then after we do that, we're going to square it. So that's going to give me negative 6, and then negative 6 squared is 36. So 36 is my new c. I just added 36 to the left-hand side of the equal sign. So I just unbalanced the equation. So if I add 36 to one side, I must also add 36 to the other side to keep the equation balanced. Now we want to find the new c for the y variables. So to find the new c for the y variables, we're going to take the linear coefficient, which is the b, right? So we're going to take the b, and the linear coefficient, the one that has just the plain old y, is the linear coefficient. We're going to take that and use the formula. So we're going to take negative 4, divide it by 2, and then square that, because that's what that says to do to find the new constant. So negative 4 divided by 2 is negative 2, and the negative 2 squared is positive 4. So that means we have, I'll put it in red, that means we have 4 is our new c for that one. Kind of color code that a little bit. So again, we just added 4 to the left-hand side, so we must also add 4 to the right-hand side to keep it balanced. So the reason why we did that is what we did is we created what's called a perfect square trinomial. So both of these are now perfect square trinomials. So we're going to rewrite those in factored form. So that's going to be x minus or plus, depending on, and this is going to be negative 6 is going to be my h, so that's going to be x minus 6. So that's going to be 6 squared plus, and then we have, for the y's, is going to be minus 2. So it's going to be y minus 2 squared. And then when you add up everything on this side, that gives me 42. So now I have it in standard form. Right, so now it's in standard form. So now I can identify the center. So I would just want to take a moment and I want to prove to you that this is correct. So remember, so I just want to prove to you about this. I just want to talk about x minus 6 squared. Doesn't that mean x minus 6 times another x minus 6? And remember, you could FOIL this and multiply this out. And if you FOIL this, you get x squared minus 6x minus 6x plus 36. And then if you combine like terms, that gives you x squared minus 12x plus 36. So do you notice that this expression here, that x minus 6 squared, when you FOIL that out, gives you exactly this, doesn't it? So this is just the same thing, but in what we call factored form. So if you were just to multiply this out, and so you wouldn't do this. So you wouldn't actually do this right now. I'm just trying to give you a little bit of extra knowledge that if you were to multiply this out, which is y minus 2 times y minus 2, because that's what squared means. If you were to FOIL this, you'd get y squared minus 2y minus plus 4, and that gives you y squared minus 4y plus 4. Notice how this matches. So notice that this notation, when you FOIL this out, gives you exactly this trinomial. So these are just their factored form. I just wanted to explain that that's what we were doing, is we were completing the square to get them trinomial so we could factor them into this version. So we can now identify the center of the circle as positive 6, 2, and the radius. Remember, this is your radius, so your radius squared, or r squared, is 42, right? So you take the square root, so the square root of 42, and if you grab a calculator and do that on a calculator, you should get about 6.48. So I hope this helps you with writing something from general form to standard form. So remember, the coefficients of the quadratic term must be 1. So the first thing we had to do was divide every single term by 2 to get these coefficients to be 1. We don't need the other coefficients to be 1, only the squared terms have to be 1. Then we move the constant over to the other side. We put the x stuff next to each other, put the y stuff next to each other, and then found the new c's so that we could then write it in standard form. Okay, so go back and rewatch it. I hope this helps.